All right, today we're going to tackle a really powerful idea in data science, principal component analysis, or PCA. Now, I know that sounds super technical, but honestly, the core idea is all about something really simple, just finding a better way to look at your data.
So here is how we're going to break it down. First, we'll look at why data can sometimes be a real mess. Then, we'll get to that aha moment, finding a new angle that makes everything click. From there, we'll actually define what these new angles, the principal components, are. Then we'll see how they let us simplify things like a lot. And finally, we'll tie it all together and see why this is such a game changer in the real world. Sound good? Let's dive in.
Okay, so first things first. Let's talk about a super common problem with data. It's often messy. And a big reason for that mess comes down to one word: correlation.
And this really gets to the heart of the problem that PCA is trying to solve. You see, sometimes the most important patterns, the real story in our data, it's not actually hidden, it's just obscured by the way we're looking at it.
Let's start with a really simple example. So imagine each of these dots is, say, a person. And we've plotted two different things about them. Let's just call them x1 and x2. Maybe it's something like hours studied versus your final test score. You can see the trend right away, can't you? As one value goes up, the other one tends to go up too. It forms this kind of diagonal cloud. Now, in stat speak, we'd say these two things have high covariance. That's really just a fancy way of saying they move together. They're correlated. And when two variables are telling you pretty much the same thing, it means you've got some redundancy. And that redundancy, that's what we can simplify.
So, if our current view is kind of redundant, what can we do about it? This is where the big aha moment comes in. What if we could just find a better angle? So what if we just completely changed our perspective? Let's forget about those old x1 and x2 axes for a second. Imagine we could literally rotate our viewpoint until we find a brand new set of axes that line up way better with the data itself. And look at this new axis U right here. It cuts straight through the longest, most spread out part of that data cloud.
And this is the whole idea in a nutshell. Our source material from AI Brilliance puts it perfectly. The most variance, the spread in the data is along this U-axis. It's the main or principal direction of the data's variation. We've basically found the direction that tells us the most about our data.
So these new, smarter axes we found, they're not just some random lines. They've got a special name, and they are incredibly important. They're called the principal components.
And just look at what this new viewpoint gets us. In our original view on the left, our variables were all tangled up. They were correlated. But in our new view, along these U and V axes, that correlation is completely gone. It's zero. The information is now independent. We've basically untangled the story the data is trying to tell.
And that, right there, is exactly what PCA is. It's a method that finds this perfect new coordinate system for our data. These new axes, the principal components, are special for two big reasons. One, they're not correlated with each other, and two, they're ranked by how much of the data's spread they capture.
So in our little example here, U is our first principal component. Why? Because it points in the direction that has the absolute most variation. And V, which is always at a right angle to the first one, is our second principal component. It captures whatever variance is left over.
Okay, so this new perspective is pretty powerful. But now what? Well, now we get to do something amazing. We get to simplify. We can actually reduce the number of things we have to keep track of.
And here is where it gets really cool. We can start to ignore things. Take a good look at that vertical V-axis. The data points aren't really spread out along it at all, are they? All that tiny little variation? It might just be random noise, a small error in measurement. It's probably not part of the main story.
So what if we just decide that the little bit of information along that V-axis isn't important enough to keep? We can literally just project all of our data points down onto the main U-axis. It's like we're squashing our 2D data cloud down into a single 1D line. And boom, just like that, we've done something pretty incredible. We've reduced the dimensionality of our data. We went from 2 features down to just 1, and we did it without losing the most important pattern. This is really the main reason people use PCA.
So all of this is pretty neat in our simple little 2D example. But why does this really matter? Well, let's scale this idea up and see where PCA's true power lies.
Imagine you're not dealing with just 2 variables anymore. Imagine you're working with data that has thousands of features. We're talking about things like every single pixel in an image, or tons of genetic data, or complex financial market indicators.
PCA lets you take that overwhelmingly complex, high-dimensional data and boil it down to its absolute essence. Maybe you can capture most of the important information in just 100 components.
And the benefits of doing this are just massive. Your computers can run calculations way faster. You're automatically filtering out all that useless noise we talked about. You can suddenly start to visualize data that was way too complex to see before. And maybe most importantly, you can make your machine learning models a lot better by feeding them only the information that truly matters.
So at the end of the day, PCA isn't just some math trick. It's a whole new way of seeing. It teaches us that sometimes the best way to understand something complex is to just find a simpler, clearer angle. Which leaves me with one last question for you. What hidden story could a new perspective reveal in your data? Or maybe even in your world?